This video is going to be on projectile motion for A-level physics. So this question that we have here, it says that a gun fires a bullet at 502 meters per second horizontally from 1.6 meters above the ground. And we're being asked how far will the bullet travel and how long will it be in the air for. And we're also told that assumed air resistance is negligible and that the ground is flat. So I find that in physics especially, drawing diagrams really helps. So let's do that. So now we have a really clear picture on what's actually happening. We can see that there's a guy holding a gun 1.6 meters above the floor and he's shooting a bullet out with a velocity of 502 meters per second. Now to work it out, we need to write our SUVAT down. So S-U-V-A-T. And these relate to the variables in the equations of motion. If you forgot them, then I'll write them down. We're going to write down the information that we know first. So we know that the vertical displacement, which is S, is going to be 1.61 meters. So that's the horizontal distance from the floor to where the event happened. Our initial velocity is going to be 0, because our initial horizontal velocity, as you can see, he's just shooting it. The vertical velocity is going to be 0 initially because he's shooting it horizontally. So that means that there's no up or down motion, it's just like this. So there's no velocity in the vertical direction, so it's 0. We know that because it's in the the vertical plane, it's going to be affected by gravity. So A is going to be 9.81. And that's basically what we've been given. So to work out the time that's going to be in the air, first of all, we have to work out its final velocity. So we can do this with this equation here. So V squared is equal to U plus 2AS, U squared plus 2AS. But notice that U is 0. So this term will just go to 0. So V squared is equal to 2AS. Therefore, V is equal to the square root of 2AS. And now we can substitute our values in. So V is equal to the square root of 2 multiplied by 9.81 multiplied by 1.61. And if we do this in a calculator, this is going to be equal to 5.62 meters per second. And now that we have this 5.62, we can then work out the time. So using this equation here, V is equal to U plus AT. Obviously we know that U is 0, so that will cancel out. So V is equal to AT. Therefore, dividing A on both sides, T is equal to V divided by A. We can substitute in, so 5.62 divided by 9.81 is equal to 0.57 seconds. So we know that the bullet will be in the air for 0.57 seconds. Now, the time is the only thing that relates the vertical and the horizontal. These things, so SUVA, is completely different for vertical and horizontal, but time links it together, which kind of makes sense. Because if you get something and you throw it, regardless of how high it is or how far it falls, if the time that it takes to get from here to here and here to here doesn't match up, then it just doesn't make sense. So the time is the only thing that links them together. So now we can write a horizontal SUVAT. So as said, time links them together. So we know that our time in the horizontal is going to be 0.57 as well. And we know that our initial velocity in the horizontal is going to be 502. And in the horizontal, the final velocity is going to be equal to the initial velocity, because when something's moving like this, there's no force, there's no acceleration on it, so it's going to stay at the same velocity. So from start to finish, it will be the same. So the final will be 502 as well. Acceleration, as just said, is 0, so we want to work out S now. So really we can use any equation that we want. I'm going to use this one. So S is equal to UT plus half at squared. Therefore, s is going to be equal to, so the a is 0. So that whole term is going to cancel out, because even though t isn't 0, t multiplied by 0 is going to be 0. So this whole bit goes to 0. So s is going to be equal to u multiplied by t, which is going to be equal to 502 multiplied by 0.57, which is going to be 286.14 meters. So therefore, we can conclude the bullet will travel 286.14 meters and will be in the air for 0.57 seconds.